Number 19 wants us to find all solutions to the differential equation y prime equals negative 5y. And it also wants us to figure out which particular solution satisfies the initial condition y0 equals 3.4. And when you originally took this test, we had only done the babiest of introductions to differential equations, and really the only thing that you knew at that point was that the only family of functions whose derivative equals the original function were the families of e to the x's. So you would have recognized that this was one of those functions where e to the x, if you took the derivative of e to the x, right, like our y prime, we would end up with just plain old e to the x when we were done. In this case, we have something that's a little bit different. We have a coefficient of negative 5, and the formula that you were taught to memorize is that that negative 5 ends up being up in the exponent's place. So really, you're just looking at something that looks like this. And then we need to figure out what that variation, the constant, in this case it's going to be the coefficient, was by using the initial conditions. But since this test, so really all you had to do was to memorize the formula and kind of use it. But since this test, you have learned how to separate variables. So I'm going to explain this problem in terms of separating variables. So it's not just a question of memorizing this formula. And that formula is this, just in case you're wondering. Oops, e to the x. So it's going to look like something like this. But I'm going to show you where that comes from using separation of variables, and that might help number 19 make a little bit more sense to you than just randomly applying a formula that you had to memorize for the test. I'm going to do this video into two parts. So if you're already pretty happy where the formula comes from and you're just curious about what happened with the initial conditions, then I would watch the second video that's going to deal with how to use the y of 0 equals 3.4. All right, so let me get rid of all of this stuff. I'm going to leave this up here. And I'll just make it e to the u, maybe up there for right now. Just as a reminder of where we're headed. And then let's think about separating variables. So if you're asked to solve a differential equation, and the technique that you learned for dealing with separation of variables was to get all of the y terms on one side of an equation. So all the y's, all the dy's on one side, all the x's on the other side of the equation, all the x's, all the dx's. And that's what we're going to use here, but right now it's a little mysterious to think why I would do that, because I really only have variables or terms involving the variable y. I've got dy, right, this is what this is, dy, and a y term. I don't have any x, I don't have any other variable. So I'm going to introduce a dummy variable here, and I'm going to use t just to remind us that it's something that I've introduced into the equation. It's not something that was there to begin with. I can't just sort of randomly slap in variables just because I want them there. So I have to be really careful about how I'm doing this. So the first thing I'm going to do is say, well, if I just multiplied the right-hand side by 1, you would not object. You'd say, yep, that's fine. You haven't changed the value of anything. And then I'm going to say, if I integrated 1, right, and I want to integrate it in terms of this dummy variable t, what would I end up with? Well, you would say, well, you would end up with just this, right? So what I want to do is say that this number 1 is really a variable or a term, a factor in this case, that's involving the variable t, this dummy variable t. So instead of just having a 1 there, I'm going to have this part dt, this differential there instead. So let me rewrite this. dy equals negative 5y times dt. Now let's separate the variables. So I want to get all my y terms on one side and have all my d terms on the other side. My negative 5y is a factor. I need to separate that out, so I'm going to separate it out by dividing negative 5y on both sides. And now I have something that looks like this. dy divided by negative 5y equals dt. So I've got all my y's on one side, dy's and the negative 5y, all my dt's on the other side, and I'll only have a dt. I don't have an actual t yet. And now I'm going to integrate. So separate and then integrate. Integrate this side, integrate this side. So over on the right, that's pretty easy. The integral of dt is just plain old t. And because it's implicit, or not, sorry, not implicit, because it's an integral without limits, not a definite integral, I need a plus c. And over on the left-hand side, you probably recognize that we've got a logarithm happening here. So I'm going to pull out the negative 1/5, and then I would just have dy over y, and the integral of dy over y is just ln of y. And there's also a plus c on this side, but I'm going to lump it in with my plus c over on the right. So now I've got negative 1/5 ln of y. That negative 1/5 came from pulling out the negative 5 coefficient of y equals t plus c. I am looking for this original function y. That was what I needed to do to begin with. So I am going to get y by itself. I'll multiply both sides by negative 5. So negative 5 on this side, negative 5 on that side. I'll end up with ln of y equals negative 5t plus negative 5c. And then I'm going to exponentiate. So e to the ln and e to all that stuff. E to the ln of y is just plain old y. And on the other side, I have e to the negative 5t plus negative 5 times my constant c. All right, we're almost there. So now I have this crazy thing, y equals e to the negative 5t plus negative 5c. And remember where I'm headed here. I knew I was going to end up with y equaling something with an exponential, like e to the something. And sure enough, there it is. It's coming out of having to differentiate the log, or take the integral of something and it ends up being a log. And I'm going to do one more thing. I'm going to use exponential log rules and rewrite y equals e to the negative 5t times e to the negative 5c. So I'm just using rules of exponents here. And remember, exponents, if you're multiplying like bases, you can just add up the exponents. So I'm just doing that in reverse. Notice that the factor on the right here, e to the negative 5c, is really just some number, right? It's the number e raised to some power, which is negative 5 times some constant c. So it's just another constant. So I'm going to replace that with a big old constant c, and then rewrite one more time. Y equals c times e to the negative 5t. So I'm almost there. This is the first part of the question that I was asked to solve. So I was asked to find a solution, all the solutions, the family of solutions to y prime equals negative 5y. Well, I did that. Here's the family of solutions, or the general solution. And this was something that you just had to memorize for this test, but now with the separation of variables, you'll understand where that actually comes from. In the next video, I'm going to use the initial condition to figure out what C is. And if you have any questions on this process of how I got from my original problem here to the family of solutions over here, send me an email.